Cryptocurrencies and blockchain technology have gained massive traction in the past decade. Blockchains emerged as the future of data storing and financing, with millions diving into the crypto ecosystems. However, cryptocurrencies are infamously volatile. As of early 2017, Bitcoin broke the $1,000 price point, which spiked almost 2,000% to a little less than $20,000 by December 18, 2017, when it reached this record high price. But soon by early 2018, Bitcoin price plunged more than 50% down to below $7,000. Many investors who anticipated further rise in price lost a ton of money. Ever since, Bitcoin has been incredibly volatile, rising and falling by an incredible volume in a week or even days and hours. Unfortunately, this volatility is not exclusive to Bitcoin. It holds true for just about every cryptocurrency on the market. This issue detracts many people away from investing into cryptocurrencies, and it further discourages steps toward the envisioned future of cryptocurrencies formally replacing fiat money for day-to-day usages. Our team tackled the issue of volatility by creating our own deflationary token called the Spark token. Deflationary tokens can help combat volatility by hedging against inflation. Our approach was to burn some percentage of amounts transferred in each transaction. This way, the total token supply will gradually decrease and the value will be worth more later. This deflationary model was inspired by the bomb token, which pioneered the idea of burning tokens in an attempt to stabilize the prices. It initiated with 1 million token total supply and a 1% burn rate. This means that when 100 tokens are transferred, 1% of it, which is 1 token, will get burnt and the recipient will receive only 99 tokens. The burnt token is forever gone. Bomb's price exploded in May 2019 as shown in the graph, though it experienced dramatic decline ever since. Admittedly, there are many problems with such a deflationary model too, with the two most crucial problems being encouraging the hoarding culture and highly questionable sustainability. People will be hesitant to cash out when they know the price will increase tomorrow. It is also unclear whether merely decreasing the supply can act as a hedge against inflation. Still, we wanted to experiment with deflationary tokens ourselves, so we created the Spark token. Spark token will initiate with the total supply of 1 million tokens like Bomb token, but increase its burn rate to 2%. This is more similar to another deflationary token called the Nuke token. Nuke was also inspired by Bomb token, and it has a 1 million initial total supply and 2% burn rate. The main difference of Nuke and our Spark token is that Nuke runs on the Ethereum blockchain while Spark runs on the Tezos blockchain. Moreover, Nuke will stop burning its tokens at some point, while Spark will indefinitely burn its tokens like the Bomb token. Cryptocurrencies run on blockchains, a list data structure connected by hash pointers. Blockchain was originally proposed in the Bitcoin white paper as a decentralized peer-to-peer method to facilitate digital transactions without third-party trust. Instead of relying on its centralized authority to oversee our transactions, Bitcoin achieves distributed consensus through the public ledger in a blockchain form. Each transaction validated through public key encryption is announced to all nodes in the network, which addresses the double spending problem by maintaining the full record of transactions. The transactions are regularly grouped into a block by miners and added to the blockchain. When miners create the blocks, they must provide proof of work that significant effort was put into the mining process. The miner must discover a nonce, a binary code that begins with a certain number of zeros. As the number of required zeros increases, the probability of discovering the nonce decreases exponentially. To incentivize miners to undergo such an arduous process, miners are granted a block reward upon successful block creation, minting new coins out of nowhere. A block also contains a timestamp, which creates a unique block hash combined with transactions and the proof of work. The next block in the chain points to the previous block's hash. Because Bitcoin naturally trusts the longest blockchain and hashes alter even due to the smallest changes, if an attacker was to forge a fraudulent chain and make other nodes trusted, he or she would need to provide proof of work repeatedly until the fraudulent chain's length catches up to the length of the current longest blockchain. The probability of successfully performing such an intensive task is minuscule, with the amount of time and computing power required. Hence, Bitcoin is deemed secure. Tezos is one of the most popular and one of the fairly new blockchains out in the market. Tezos primarily differentiates itself from other blockchain platforms by implementing a self-amendment process, eliminating the need to fork the network into multiple blockchains and preventing community divisions. In addition, Tezos employs the proof-of-stake method to reach consensus. Proof of work has proven to be immensely power and time-consuming, as the mining power increasingly grew demanding. Proof of stake addresses the issue by introducing a democratic method to reach a consensus while incentivizing nodes to be honest by holding them at stakes. Tezos also facilitates formal verification, a technique of mathematically proving smart contracts' correctness. Instead of, instead of performing a series of unit tests, formal verification provides a confirmation for all inputs, including edge cases. This can help catch serious flaws in programs. This is a demo of our project. This is a code for the token contract we've written in Michelson, a stack-based functional programming language for Tezos. We start by declaring a parameter, which is a pair of recipient's address and amount to transfer, and declaring a storage, which is a pair of map containing addresses that points to their balances and the total token supply. The code initializes by checking if any Tezos currency was sent to our contract because we do not want any Tezos currency to get locked in our contract. Next, we check if the sender is in the ledger, and if sender is in the ledger, then update the balance accordingly, and if not, we return an error. Now, in this code, we burn 2% of the transferred amount, and finally, we update the balance for the recipient. Now we're going to run our contract. We run the command with sender's address and the recipient's address, and we send 10,000 tokens. And here we can see that during the transaction, 200 tokens have been burnt, which is 2% of 10,000. Now we're going to check the final balance after the transaction. Here we can see that from initial total supply of 1 million, 200 tokens have been burnt in a single transaction, and now we only have 998,000 tokens.
Lessons learned. We entered this project knowing basically nothing about blockchains and the economics of cryptocurrencies. It soon became apparent that the learning curve was steep. Setting up the Tezos environment alone caused enough troubles till the very end of the project. We couldn't inject any operations to the network for some reason, so we had to test everything via mock-up protocols. Programming in Michelson posed an issue too because it was vastly different from typical languages that students know of. We didn't have much experience with low-level stack-based and functional languages like Michelson, and the syntax was very peculiar. Nonetheless, we patiently went through the tutorials and got a good sense of Michelson's syntax. But then, even after we familiarized ourselves with Michelson's syntax, we weren't sure where to start with our coding of our smart contract. We had to surf the web looking for the right tutorial, which we eventually did through persistence, and we were able to code the Spark token contract successfully. We finally tested our token contract, and we were able to confirm that the contract ran just fine with tokens burning. In the end, we learned so much about blockchains and the economics of cryptocurrencies. We now understand how blockchains secure transactions and why cryptocurrencies are so volatile. And as for what we learned as a team doing this project, we learned that the value of persistence and communication. Whatever the problem we came across, sooner or later, we got past the hurdle and continued to move forward, but it depended on how much we looked for answers together.
Besides from Michelson, which is a domain-specific stack-based language to the Tezos blockchain, we also took a different approach and tried using Lego, a high-level smart contract language designed for developing larger contracts than those naturally written in Michelson. It is an imperative language that compiles down to clean Michelson code, featuring 3 different syntaxes and a simple type system, which will abstract the stack management and allow us to create a more type-safe, readable, and efficient smart contracts. The extension for VS Code and the simplicity to install the command line with Docker is also a big plus. So unlike Michelson, developers can get started within just a few minutes. However, with the limited time of the project and our focus on Michelson in the beginning, we weren't able to produce a fully working smart contract in Lego. But we would love to extend our work with Lego to produce a more sufficient smart contract. So unfortunately, because we couldn't inject any operations to the Tezos mainnet, we weren't able to deploy our token contract and release Spark token to the general public. Later, when there's an opportunity, we wish to fix this issue and have stock token traded and observe the change in prices and be able to analyze the data for further research on deflationary coins. Last but not least, while exploring our options to combat inflation, we came across stablecoin, which is the most prominent solution to cryptocurrency price volatility nowadays. There are two kinds of stablecoin, asset collateralized and non-collateralized. Asset collateralized coin are pegged to fiat currency or commodity. Thus, they provide users with price stability while compromising centralization and dependence on regulation, also requiring more trust from users and financial audits from third parties. Non-collateralized coins offer full decentralization and independence from any other currencies, but can be complex to build and require constant supervision via smart contracts. In the future, we'd love to explore different ways to mitigate the volatility issues, creating a coin with more utility while keeping the nature of it, decentralization. Thank you very much for listening.